So we're starting to score our unit 6 through 7 FRQ packet. Here we have the first question. This is from the 2017 exam, number 2. So if you'd like to look at the scoring guideline in more detail, Google AP Statistics 2017 scoring guideline and go to question 2. So for this first part, it asks you to construct and interpret a 95% confidence interval for the proportion of all customers who have asked for a water cup when placing an order will fill the cup with a soft drink from the beverage fountain. Not nice. So anytime, even though it didn't say find the assumptions or check the conditions, unless it explicitly tells you they've already been checked, you have to check them. So my 2 assumptions, the first is that I have a random sample of customers or SRS of customers. And then the sampling distribution is approximately normal because, and I do n times p and n times 1 minus p. I show what they're equal to like that, and then they're greater than or equal to 10. I include the name of my procedure. Remember, that's extremely important. We're putting the name instead of putting the formula. So you have to have the name. Then for my calculations, I wrote p hat, but all they're going to look for is the interval. And then my conclusion, we are 95% confident the population proportion of customers who will ask for a water cup then fill it with soda is between 0.18832 and 0.38668. So they got 0.1883 to 0.3867. That's the same thing. They checked random sample, large sample. And then okay, so they worded it a little bit different. I actually like this better. We can be 95% confident that in the population of all customers in the restaurant who ask for a water cup, the proportion who will fill it with a soft drink is between the 2 numbers. So I don't think mine would be counted wrong, but I actually like what they did better because it's more clear. So that precision of language thing we talked about before, I really like that wording. I might start doing that sometimes. And then what you should do for the next one, we want to estimate how much money it's going to cost us, or it's going to cost the restaurant. If 3,000 people ask for a water cup times 25 cents per person, this is the lower bound for the proportion of people I expect will fill it up. To my upper bound, I plug in my upper bound in the same spot. So this is my new interval. That's my interval for what the mean cost would be for 3,000 cups, according to my prediction. At a cost of 25 cents per customer, a 95% confidence interval for the cost of the restaurant in June is 141 to 0.25. Yep, essentially the same numbers. I'm off by a penny, but that's because I didn't round here. So actually, they're off by a penny. I am more accurate. Not that it's a competition. Okay, so section 1 consists of step 1 in part A, step 2 in part A, section 3 consists of step 3 in part A, and section 4 consists of part B. Okay, so this is section 4. What do they call step 1 and step 2? So they're scoring, a lot of times this is scored together, and then this is scored, but they're scoring all of this together. And then section 2 consists of I'm sorry, they did not do that. I don't know what's wrong with me. So this is section 1 right here. It's so pretty. Ignore that. This is section 1. This is section 2. This is section 3. And part B is section 4 right here. So section 1, essentially correct if the one sample Z interval for a proportion is identified either by name or formula. So that's what this is. A one sample Z interval for proportions is the same thing as a one proportion Z interval. The one sample Z interval for proportions is the full proper name, but that's the same thing, what we wrote. And both conditions, random sampling. So if you put SRS, that's the same thing. And large sample, this is what they mean by large sample. I like to include it with the normality because they ask other questions like this, and they ask, like, what does this mean? It means that the sampling distribution is approximately normal. Okay, so essentially correct if you have all three of these things, both assumptions and the name. Partially correct if the response identifies the correct procedure but adequately addresses only one of the two conditions, or if the response does not identify the procedure but adequately addresses both conditions. So basically, if you forgot one of those, you got to partially correct. If you forgot two of those or more, so if you forgot the assumptions altogether, that would just be incorrect. Stating the large sample condition without verifying it is not sufficient. They must use specific numerical values to adequately address the condition. So this is specific numerical values. If the response includes additional inappropriate conditions, such as n is greater than 30, or requiring a normal population, okay, I didn't say normal population, but I should probably put sampling distribution as normal. So sampling distribution is what's normal, not the population. We have definitely not been doing that, but I would maybe start. Any statement of hypotheses, description of the population, or definition of the parameter should be considered extraneous. However, if such statements are included and incorrect, they're considered poor communication in terms of holistic scoring. Okay. Section 2, essentially correct. The response gives the correct 95% confidence interval. Supporting work is not required, but if included, it must be correct. If you included the work, but it was incorrect, but appropriate, it's partially correct. If your response is correct, I don't know why that would be the case. Or if the student gives an incorrect but reasonable confidence interval with appropriate supporting work shown. For example, if you got your Z star wrong, so if you got 1.6449, so if we do it in the calculator, there's no chance of partial credit here, but I think it's well worth it. Because if you do the work and the work is wrong, you also get partially correct anyways. A confidence interval has to have both endpoints inside the interval from 0 to 1 to be considered unreasonable. Oh, if you have, yeah, if you have both if you have them outside the interval, it's unreasonable. If they're inside, it would be reasonable. Okay, so section 3 is my conclusion statement. Essentially correct if you have the following three components. Conveys inference about a population proportion. So I said population proportion. You also could have said the true proportion or the proportion of all customers. Or you could have had all three of those and then you're triply good. Demonstrates a clear understanding that the parameter is the proportion of water cup population that fills the cup with a soft drink. So the customers who will ask for a water cup then fill it up with soda, I think that qualifies to demonstrate a clear understanding of the parameters, the proportion of the water cup population that will fill the cup with the soft drink. So I don't think it's quite as clear as what they wrote, but I think it's still good. Mentions 95% confidence and interprets it correctly using words such as we can be 95% confident, or with 95% confidence, or I can. Partially correct if you have an appropriate interpretation that includes the first component and only one of the other two components. So you have to have that first component. Or if the response provides a correct interpretation of the confidence level in context without interpreting the specific interval. I don't know why you would have done that, but if you did, that's partially correct. Section 4, essentially correct if the response gives a correct interval estimate for the cost to the restaurant and shows enough work. So here's my work. And here's my interval. So I got essentially correct here. Essentially correct if the response gives a correct interval estimate for the cost to the restaurant and shows enough work to indicate how the interval was found. Okay, so we did that. Partially correct if they give the correct interval estimate for the number of customers, but you didn't multiply by 0.25, or if you gave it for the cost per customer, but you didn't multiply by the 3,000. Or if you tried something else that was reasonable, I guess. Or if you just put the interval with no work, that was also partially correct. If you got your interval wrong and you showed work here, full credit on B. So if you somehow got your interval wrong and you showed work here, full credit on E. That's why if you don't know the interval, it's best to make one up. So if you just can't figure it out, if you're completely stuck, make up an interval to use in your conclusion statement and any additional parts that might be there. Remember, your p hat should be in your interval, and your interval for proportions have to be between 0 and 1. So don't give an unreasonable interval, because that can take off additional points in places. Not here, but it can in other places. So essentially correct. Counts each section as 1, partially as 1/2. So +1, +1, +1, +1. So I got 4 out of 4. They don't actually give 3.5 out of 4. They look at it holistically. So for example, if I had taken off here because I didn't put sampling distribution, I would have given myself partially correct. Holistically, I would have looked at that and said, she knows what she's doing. She didn't say population is normal. She just didn't make it clear the sampling distribution is normal. I'm going to give her a 4 out of 4. But if I had done other things that were wrong, like maybe I technically got credit on my conclusion, but it was worded really poorly, or maybe my work here was not as good as it should have been. They look at it holistically. Overall, did they do a really good job, or overall, did they make a lot of mistakes? Did they get points based on technicalities? They look at it holistically to decide whether to round up or down. So that's the end of this video. See you in a few minutes. You'll hear me in a few minutes when you do the next one.